Assalamu alaikum students. So today I am going to tell you that how you can differentiate between a prime and composite number in a very easy manner. You can do it in just 10 seconds. So please be focused and understand the concept. So the first of all I would like to tell you that you should read and also learn the prime numbers which are given in this screen. At least up to 100 you must remember the prime number. But how you can determine that whether a number is a prime number or a composite number? First, for example, the first part we are going to solve the first part, that is 87. So we have to determine whether it is a prime or a composite number. So first step is to think about a number whose square is greater than 87. Like for example, if I say 9 into 9 is 81, so it is smaller than 87. Then we go to 10 into 10 is 100. So this 10 is a number whose square is greater than 87. Now we have to consider all the numbers, all the prime numbers which are less than 10, like it is 2, 3, 5 and 7. And now what we have to do is that we have to divide 87 with the 2. Is it in the table of 2? No, because it is not ending on an even number. Is it in the table of 3? Yes, we should do it. 3 2s are 6 and 9 3s are 27. So it is divisible by a prime number. That's mean that it is having more than two factors. That's why it is not a prime number, but it is a composite number. Now going towards the second part, that is 67. So our first step is to determine a number whose square is greater than 67. So it will be 8, or 8 8s are 64. No, 9 9s are 81. So the number is actually 9. After taking this number, we have to consider all the prime number less than 9, that are 2, 3, 5 and 7. So again we will check that either 67 is divisible by 2. No. It is divisible by 3. No. It is also not divisible by 5 because it is not ending on 0 or 5, and it is also not in the table of 7. So it's mean it is not divisible by any of the prime number. So this it's mean that its only factor will be 1 into 67. So because it is having only two factors, that's why it is a prime number. So you can also locate it in the table like this. It's a prime number. So it is very easy method to differentiate between a prime number or a composite number. Question, they are saying that find out the prime factorization of each of the following numbers, leaving your answer in index notation. In this question, we first have to find out the prime factorization. Like we are going to solve the a part, that is we are going to find out the prime factors of the number 72. So by division method, how we can do it? Like 72, we have to divide it on the smaller prime number. So before solving it, I would also recommend you that you should understand and you should learn the numbers, the prime numbers below 20 at least. So the first smallest prime number is 2. So we divide it on 2. 3 2s are 6 and 6 2s are 12. Again it is divisible by 2. So 2 1s are 2, 8 2s are 16. Now this is also again divisible by 2. 9 2s are 18. 3 3s are 9 and 3 1s are 3. So the number 72 is having the prime factor 2 into 2 into 2 into 3 into 3. Now we have to write it in index notation. So we'll sum up the power 1 2 and 3 to raise power 3, and 3 to raise power 2. So this is how we can determine a factor of a number using the division method and write it in index notation. Similarly, I am going to solve the part D of this question, that is the number 630. So again 630. So is it divisible by 2? Yes. 3 2s are 6 and 2 1s are 2 and 5 2s are 10. Now this number is not divisible by 2, not divisible by 3, it is divisible by 5. 5 6 are 30 and 5 3s are 15. Now this number is divisible by 7 and 3 3s are 9 and 3 1s are 3. So its factor will be 2 into 5 into 7 into 3 into 3, and in index notation we can write it as only 3 to raise power 2. All other numbers are singles. So this is how you can find out the prime factors of a number, and then you can write it in index notation. I hope you would have. So now we are going to solve question number 3 from the exercise 1A from the book D1. In this question they are saying that find out each of the following by using the prime factorization. So let's do the first part, that is 1764. Okay, so first of all we have to find out its prime factors, and we can find the prime factors by using this method of dividing this number on the smallest prime number first of all, that is 2. So it is a 2s are 16, a 2s are 16, 2 2s are 4, then again it is divisible by 2, so it will be 4 4 and 1, and then again it is divisible by 3, 3 1s are 3 and 3 4s are 12 and 7 3s are 21. Now again 3 4 3 4s are 12 and 3 9s are 27, and now it is divisible by 7, 7 7s are 49 and 7 1s are 7. So its factor will be these 1764 first of all, and now its factors 2 into 2 into 3 into 3 into 7 into 7. Now we will write it in index notation: 2 to raise power 2, 3 to raise power 2 and 7 to raise power 2, and under root has the power 1 over 2. So because all of these numbers are under root, so we will write 1 over 2 with each of these powers, and now we will cancel these powers with 2. So the remaining numbers will be 2 into 3 into 7. So its answer will be 3 2s are 6 and 7 6 are 42. Okay, now we are going to solve a question of this part, that is about the cube root. So we will solve the part D. In part D they are giving us to find the cube root of 1728. So first of all we will find out the prime factors of 1728. 1728 is divisible by 2. 8 2s are 16, 6 2s are 12, 4 2s are 8, again 2, 4 2s are 8, 3 2s are 6, 2 2s are 4, again with 2, 2 2s are 4, 2 1s are 2, 6 2s are 12, again by 2, 2 1s are 2, 8 2s are 16, and now again with 2, 5 and 4, 2, 2 2s are 4, 7 2s are 14, and now with 3, 3 3s are 9 and 3 1s are 3. So its prime factor will be 2 to raise power. How many times the 2 is repeating? 1, 2, 3, 4, 5, 6. And how many times 3 is repeating? 1, 2 and 3. And it is under the cube root. And cube root has the power of 1 over 3. So now we will simplify this power. So this 3 will be cancelled by this and this is cut. So it's 2 to raise power 2 and 3 to raise power 1. That is 2 2s are 4 and 3 1s are 3 and 4 3s are 12. So this is how you can find out the solution of this question of a square root or a cube root using the prime factorization. I hope you would have understand this concept. Now we are going to solve the question number 4 of exercise 1a from the book D1. In this question, they are saying that given that the prime factorization of 9801 is 3 to the raised power 4 into 11 to the raised power 2, find the square root of 9801 without using a calculator. So first of all, we will write this question as 9801 and then its prime factors are 3 to the raised power 4 and 11 to the raised power 2. Now we know that the power of 1 root is 1 over 2. So we will multiply it with 1 over 2. And this power will be simplified in this way. So 3 to the raised power 2 into 11 to the raised power 1. That will be 3 3s are 9 and 11. And now we will multiply 11 with 9 and our answer is 99. Similarly, in question number 5, they have given us the prime factors of 21952 and find out the cube root. We have to find out the cube root. So 21952 and we are going to find the cube root. They have also given us the prime factorization. So let me write the prime factors that are 2 to raise power 6 and 7 to raise power 3. And now we will multiply its power with this 1 over 3 because it's a cube root, so its power will be 1 over 3. So its power will be simplified as this as the previous question. So 2 to raise power 2 into 7 to raise power 1 or 7. So it will be 2 2s are 4 into 7. 7 4s are 28. So now we are going to solve the next question. In this question, they are saying to estimate the value of each of the following. And if we look at the first part, it is 66. So now we have to estimate. So when we are going to estimate, it's mean that we are not going to use calculator. We are not going to calculate the exact value, just estimate. So think about a number whose square is just near to 66. So it is 8 8s are 64. So that number is 8. So we can estimate, or we can say that it is very near to 64 on root. So its answer will be 8. Okay. Similarly, in question number 2, you can see that it is 80 and the perfect square near 81 is 81, that is 9 into 9 is equal to 81. So we will consider 80 as very much near to 81 and then find out its square root, that is 9 to raise power 2 under root and 9. So its answer will be 9. So this is how we can estimate and find out the values. In the question number 7, they are saying us to use the calculator and find out the values of each part. This question is actually very easy. You can use the calculator. You just know different keys on the calculator, that how you can find out the square and how you can find out the under root of any number. Like in part A, if we solve it, 7 to raise power 2 minus 361 under root plus 21 to raise power 3. So first of all, 7 square, the square of 7 is 49, minus, now we will find out the under root of 361, that is 19, and now we will find the cube of 21. So 21 into 21 into 21, its answer will be 9261. 9261. And now we will just add and subtract 9261 plus 49, and then we will subtract the 19. So our answer will be 9291. 9291. So this is how you will solve the rest of the part of this question. Now we are going to solve question number 8 of exercise 1A from the book T1. The question is, the area of a square photo frame is 250 centimeter square. Find the perimeter of the photo frame, leaving your answer correct to one decimal place. So first of all, we will write the information they are giving. The information is that square of photo frame is 250 centimeter square. So now the formula of the square is that L to raise power 2. So if it is L to raise power 2 is 250, and we want to find out the side length of one side, first of all we will find the under root of 250. So this under root will be cancelled by this one. So the length of one side will be the under root of 250. So for now we will find the under root of 250, that is 15.81. 15.81. So this is the length of one side. Now if we want to find out the perimeter, the formula of a perimeter is 4L. So 4 into 15.81 will be the perimeter, that is 63.24. 63.24 centimeter, and they are asking us to write to one decimal place. So it is I will write it in just a simplified form. It is 63.2 centimeter. Now in question number 9, the volume of a box in a shape of a cube is 2197 centimeter cube. Find the area of one side of the box. So in this question they are giving us the volume of cube, and volume of the cube is 2197 centimeter cube. And because we have to find out the area, so first we must know the length of one side. And how we can find, uh, first we know the formula of a volume of the cube is L to raise power 3. So if we find out the cube root of the uh, of this length, then we can find the length of one side. The cube root of this number is 13, and now if we find we have to find the area, so it's mean that we have to multiply, or we have to find the square of this number, that will be 13 into 13, that is 169. Question number 10 from the exercise 1A of book D1. The question is, determine whether each of the following is a prime or a composite number. So we are going to solve the first part of this question, that is 667. So first of all, we have to see that, as I have explained in this question number 1, that we have to pick a number whose square is greater than 667. So we will pick any random number. Say for example, we took the number 23 from this prime number table. The square of the 23 is 529, which is less than 667. Again, in the next we have the number 29. The next prime number is 29. Its square is 841, so which is greater than 667. So it's mean now we have to check the numbers starting from 2, 3, 5, 7 till the number 29. If this number 667 is divisible by any of this number, then it's mean that it's not a prime number. And when we check it, we find that 667 is divisible by the number 23. Like I am going to solve it. 667 is divisible by the number 23, and the answer is 29. So it's mean that it is not a prime number, but it's a composite number. Similarly, if we look at the second part, the second part is 677. Again, in this part we have to check, because it is also under the number 29. So we have to check right starting from the number 2, 3, 5, 7 till the number 29. And if we check, it is not visible by any of the prime number till the number 29, which means that 667 is only having the factor 1 into 677, so it's a prime number. So similarly, as I have explained part 1 and 2, you can solve the part C and D as well. Now we are going to solve question number 11 from the exercise 1A from the book D1. The question is, if P and Q are the whole numbers such that P into Q is equal to 37, find the value of P plus Q and also explain your answer. So the information that is given in this question is that P into Q must be equal to 37, and these two numbers are the whole numbers. These two numbers are the whole numbers, and we also know that 37 is a prime number, and a prime number is the number which is only having two factors, which means that its factor will be 1 into 37 is equal to 37. None of the other number can be product themselves into 37. So these two numbers P and Q must be 1 and 37. And if we add these two numbers, and if we want to find P plus Q, then it will be 1 plus 37, and its answer will be 38. So this is how this question is solved. In the question number 12, the question is, if n is a whole number such that n into n plus 42 is a prime number, find the prime number and also explain your answer. So the information given in this question is that n is a whole number. N is equal to whole number, or the next thing is that n into n plus 42 is a prime number. So now, for example, if we take n is equal to 1, so we'll write 1 into 1 plus 42 and try to find out its answer. 42 plus 1 is 43, and 1 into 43 is 43, which is a prime number. So this is how this question is solved. Thanks for watching. Allah Hafiz.